Alright, you guys, so welcome to Material Science. This is my first time trying to videotape myself. We'll see how this goes. But I thought that I would try to do as much as I can to make it feel like you're in the classroom, so you can see me in the classroom. We're going to see how well we can actually watch this video. Might have to learn on where to space myself. But our big goal today is to figure out and get an understanding of what material science is and how an engineer define that term. So we're going to watch a little video and then we'll get that definition in.
Materials are all around us, makes up everything that we use from day to day. But one thing a materials engineer will do is try to make those materials better.
I think material science and engineering is basically when engineers take materials that are in everyday use and we look at it in the microscopic scale and the atomic scale and then try to enhance them into like our macro scale everyday materials that we use.
You use materials everywhere. We're currently standing in a building made of materials, made of concrete and steel, and all of those had to have been studied at some point in order to know that they're the most structurally sound materials for this application.
Everything in the world is made up of materials, right? And those materials, what we see macroscopically, like a piece of steel, just looks like one hunk of steel to us. But actually there's a bunch of little particles that it's made up of. And how those are arranged changes how strong the steel is, how easy it can bend, when it melts and things like that. So material science and engineering is actually controlling that so that we can change how strong the steel is or anything. We also do polymers and plastics, ceramics, and electronic materials also.
Using science and engineering to make everything better in our world.
We can look at a failure of a piece and determine why it failed, how it failed, if the similar piece that's in use will fail.
The more efficient we can make batteries, it'll help consumers a lot.
We need things that are more efficient with energy, we need things that are recyclable, or even such things as being tougher, stronger, more resistant to corrosion, environmental things. So it can span pretty much all the spectrums of the industry out there in the world.
We have higher demand for electronic components that need to be smaller and lighter. So you need to come up with new materials that can handle such capacities.
There's only a certain amount of different elements in the earth. And a lot of things that we use to make things like TVs and electronics and things like that are limited. So if we can figure out how to recycle them and reuse that, it'll be more cost effective.
Another realm of materials that's going to, I think, be on the rise in the future is going to be multifunctional materials.
Life cycle, the whole system. What's going to happen to this in the end? Things like plastics and stuff, a lot of people are worried about landfills and things like that they don't break down very well. So there's people working on polymers that are made out of biomaterials like corn and potatoes and things like that will actually biodegrade.
I feel like I have so many options to choose from and so many different areas I can go to.
To make technology greener and as well keeping it friendly enough for everybody to still want to use in everyday applications and not make it a big hassle for everybody to become a green society.
Ames Lab is located on the edge of campus and it allows a lot of students to have research positions with professors or scientists to allow them also the opportunity.
The visit I had at Iowa State sold me. The department up here is one of the most up-to-date, I think, advanced laboratories we have for materials engineering, and the community we have, the access we have to professors and research and things is just an opportunity you can't pass up.
Okay, so hopefully that gives you a little feel for what material science is. Whenever we define material science, so what I want you to have in front of you right now is your packet. Okay, so you got this in class the other day, and we are on that page where it's having you define material science. So the definition of material science, and remember you can pause this at any time, you don't have to go as fast as me, but the study of solid materials available to us and how they can change or be changed or manipulated to perform certain tasks. So it is literally the study of solids. You know, we ignore solids whenever we think of chemistry classes a lot, physical science classes. Solids have been ignored. Material science is the chemistry of solids, and how can we use those honestly to make our life easier? So there's an article that's in your handout. It's the very first article there, and what I want you to do is read that article for homework, and then you're going to QC squared the article. So whenever I talk QC squared, this is what I mean. So Q stands for question, C comment, and then the second C connection. So when we think of a comment, think of like opinion. When you think of a connection, relate it back to something that you know, maybe from another article, from your own personal experience, personal history, something like that, and make that connection there. So when you go through the article, you can highlight, you can write off to the side, but I want you to be thinking from this point of view. And then I want you to do the questions that are following that article. And this is all in your packet. So again, the article looks like this. It's the first thing you see in your packet, okay? And then the questions that follow that article are right here, okay? And it looks like this. I don't know how well you can see this or not. So that's it. So we've defined material science. And then again for homework, I want you to be ready next time you come into class, have this article read, and have those questions answered. All right, we'll see you soon.